Hello and welcome back to Diving Deep Within the Code with me. So, if what this series is going to be all about is just talking about refactoring code and just kind of giving some tips on what refactoring is and how to do it kind of safely and make sure that you can do it in a way that doesn't cause more problems for yourself going into the future. So, some of you might be asking, what is refactoring? So, refactoring just means that you're making some kind of a change to the behavior of your code. So, you might not necessarily be kind of adding a new feature, but you might be removing something out of it. You might be moving some code from somewhere else. You might, just want to make the readability nice, and you could be just speeding up something or making something reduced in storage. So those are just kind of some of the ways that you might refactor, and there are maybe some others that I'm not covered right now, but I'll add those as we go along, and if we discover any more. But before you ever dive into refactoring, you kind of want to cover any code that you're about to change with unit test. Now, there's kind of two concepts here when you talk about a test, especially a unit test. There's code coverage and then the unit test itself. So for code coverage, or let me just start with a unit test. A unit test, you can think about that as something that flexes the actual functionality of a code. So, if we had like a little toy robot sitting here on our desk, that inside the toy robot are all these kind of wheels and spinny bits. And if we were making some testing mechanisms and we tested just the internals of that machine, that would kind of be a unit test, right? Like, we're never going outside of our little toy bird. We're just testing the insides, the units within that bird itself, right? But then there's other kinds of tests that you might have heard about. Like, one is called an integration test, and another might be called an end-to-end test. So in an integration test, you're kind of specifically targeting something and from external, but it's very, very specific. So like we can go to like an example of Twitter. So we were building a Twitter clone. And let's just say that we have the create new user experience. Well, if we were building an integration test, we might want to hit the create new user endpoint directly. And by hitting it, we might expect to get some kind of error message if we don't have our JSON formatted just correctly. So we hit that endpoint and we've been given some special token because we know all the internal API calls to get, or we just generated that for this specific test. And we hit that endpoint and we get that right error message out and we close out the test. Whereas an end-to-end test might test something a bit more general, like creating a new user experience. So with the create new user experience, that's something that I, as an actual client for Twitter, would be going through, right? So if I'm logging on twitter.com and I am creating a new user account and going through that whole experience and that whole wizard flow to create that new user account, that would be doing an end-to-end test. I would just be doing it manually. And so if you automate that, then you're building an end-to-end automated test, right? Whereas an integration test is going to be very, very targeted. It's not necessarily going to have to go through the whole experience, right? Like, a client isn't going to know anything about a token or anything like that. Whereas an integration test might have a special token that allows itself to make an authorized call to an endpoint. And it's just testing the format of the JSON going into that endpoint. It's not testing the authorization mechanism. So you can see an integration test, it sits nicely in between a unit test and an end-to-end test, because an integration test lets us test very, very specific errors or functionalities with some assumptions that we can't make in an end-to-end test environment. End-to-end, you have to gather all of that stuff as if you were the user of your site. And then once again, going back to a unit test is testing a very specific piece of code that is internal and it never leaves that server or that piece of code that we're running, that executable on the machine, we never leave it. We always stay within it. So if you take this piece of code here, this is all internal calls. It's making or it's reading a file that's on the OS. And that's a very fair assumption to make in a unit test, because all OSs are going to have file systems. So this unit test is just testing all the stuff that's going to be on the machine, and is a totally fair assumption. We never make an outbound call. So all of that explained, let's kind of dig deep into this topic of shielding, or I guess I explained what unit test is. There's also, I guess, a topic of code coverage. So code coverage is just, there's a tool here. When you have a unit test, you can check the code coverage on it. So if I run this, there is a window for checking the code coverage on that, and I'll have to show that. I'll just show that in a different video. But code coverage is just the concept of, it's just a percentage of how many lines of code are actually covered in your code. So it's pretty straightforward. And these are going to be covered by usually unit tests in your code. So this whole function right here is currently being covered by this test case here. And so if you dive into all the different paths that might happen in here, right now it's a very simple flow, right? Everything that comes through here is going to go through the exact same path and get to an exit. So you can end up writing one unit test, but say you add an if statement somewhere in here. Now you've created two paths to go through. And so you might have to write two unit tests, that test each different path that go through your code to get to 100% code coverage. We'll discuss that in the future, but just know that if you ever hear that, that's kind of what people are talking about, is just having maybe high code coverage for their code. And some people try to aim for 100%. That's not really doable. And there's a lot of people that agree that that's not very useful, and it makes it very fragile and very painful, and it disincentivizes people making unit tests, because every time you change the functionality of your code, something's going to break. Whereas a unit test, it should really test features once again. Like we'll get further along in this exercise, and you'll kind of see how the way I've built my unit test for this is not really testing the function, but it's testing the business logic. Like it's testing exactly what I want, what I would care about with this function. So someone can come back later and recode this and gut this function and make it do completely different stuff and write totally different code. They can even trick my unit test. But at the end of the day, my unit test is testing exactly what I care about, so that in the future, I don't have to keep fixing my unit test every time I make changes to here. So with that all out of the way, I just want to talk about the concept of shielding our changes with unit tests. So the reason why you might, like as I was kind of explaining before, the reason when you look at all the different ways, and I have the different ways that we're going to discuss refactoring over here, when you look at all these different ways, it's very easy to introduce bugs into your code. And if you've been coding for any amount of time, you know that it's very difficult to change an old piece of code and not break something way further down the line, especially if a couple of months have gone by and you haven't touched your code. It can be really hard to know if a change in one area is going to break another change somewhere else. And so that's why we use the safety net of unit tests to kind of assuage those fears. So by making these unit tests, we make this nice little shielding that tells us, well, if my unit tests are passing, then I know that the change in code that I did here is totally fine. And I don't have to go through panicking and doing a lot of manual testing, because I've already invested in a pretty decent unit test suite. So I'm good to go because I see all my green check marks. Now, you might have kind of been on projects, especially personal projects, and you might not have had any unit tests in those projects, and you might have felt that, oh, well, my project's not big enough to have unit tests. Well, the truth is that you should have unit tests on day one. In fact, to me, a project is not complete until it has a unit test in it. And the first feature that you've coded is not complete until it has unit tests in it. So it's something that's actually really easy to implement, and I'll show it to you kind of as we go through here. But it's really that extra step that can save you a lot of time and make coding a lot more fun for you, because you always have that little safety net and you always have the validation over here that everything ran as I expected it to. So let's kind of dive into it. Over here on the left, you can see that I have some setup done already. I already wrote some code for kind of a demo scenario that we're going to walk through. This code is all going to be available in a repo. I'm eventually going to have the link up. So by the time you see this, you should see a link to the repo that has all this code in it. But you can see over here that I have just a bunch of folders. Well, I have one project called Refactoring, and there's a bunch of folders inside of it that are just going to be covering all the, there is a folder that corresponds to the video that we'll be talking about. So the first video that we're talking about is shielding changes with unit tests. So in here, we have all the project code that we're going to be using. Don't be fooled. Program is sitting outside of it, and program is just going to be where we run all of our testing from. So if we want to see console output, we can run it from here. I tend to want to run all my stuff out of unit test, so I don't tend to use the console that much. But you know, if you're fresh to coding, you probably use the console a lot just to validate your input. So and so in here we have two files. I have events parser and I have models. So the problem that we're about to take on is just assume that we have some text file that gets passed to us, and it just has a list of names on it. So I know I call this the parse event function, but we're going to be growing on this in the future. But right now, we have a file that just has a list of names in it. So it looks like this: Janet, Jack, Jake, Melinda, Sam, yada, yada, yada. And so this file has a list of names in it. And, you know, maybe in the future, this list of names is going to correspond to how many people got invited to our event. And these are how many people that we need to eventually send emails to give them invites to our event. And, you know, in the future, maybe this file would also have their addresses, or all kinds of stuff, right? You know, we're just kind of starting out with a base example of kind of what, you know, it's just a very basic problem of parsing a text file to get some information out of it so that we can convert that into a much more language friendly construct. So a list of names or a list of strings is a much more language friendly thing to work with, and then we can manipulate that and do all kinds of neat, cool stuff with it. So like I said, a very basic problem. And yeah, in this case, we make the assumption that the list is going to come to us in the format of a text file. So, you know, there's a lot of different formats that it might come in. If this were an API, it might come to us as a JSON. Maybe if it were a SOAP kind of API, it might come to us as an XML file. Who knows? But in this case, it's coming to us as a file name. So I have this code already coded up right now. So we'll just kind of quickly go through what all it's doing. So like I said, I just wanted to grab a list of names out of this this file. And you might be wondering what exactly is a name. If I click F12 on this, we can see that a name is just a struct that has these attributes to it. So today, all it has is the string name. In the future, like I say, we might convert this into some other, we might change the name of the struct to something else. We won't change it to events because that's already reserved in the language of C#, but it could be changed to whatever we want. But yeah, right now it's just kind of a struct that's wrapping this public string name. Now you might be asking, well, why do you have a struct for this type? Like, why not just change this to string, make it easy on everybody? You know, and everybody kind of inherently knows what it is instead of you kind of making life harder. Well, the reason I didn't do that is because a string is, one, I don't get any context of what's in this parse events from string. So say that, you know, this data type is floating around in my program somewhere else. I don't know that it's come from parse events. But now I just know that it's a list of strings, and that's just floating around my program. Um, maybe 1,000 lines of code away, 4 functions up the stack. It's just like you don't know where this list came from. Whereas if you knew that this was a list of names, well, you can immediately start to operate on that. But if you have a list of strings, you as a coder don't know what's in that list right now. It could be literally just a list of random strings, like, you know, just da and da and da, da, da. So you're parsing like an alien language at that point, instead of just being able to directly know that, okay, this is a list of name data types. It's a very simple data type, but at least I have a little bit more context. And if I click F12, so like I say, you're 5 functions away, but you click F12 and you pop into this project, and now oh, okay, this was from the shielding changes with unit test project, and right next to it was event parser. Oh, okay, I can see how it was being used. So it was just a little hyperlink to tell us, oh, hey, like this is a struct, this is a model that we're using over here in this section of our project, right? This library over here. And like I said, you may not be working inside this library with list names. You could be working in a totally different library that you've created, and you just want to remember where in the world, what is this list of strings doing? So that's one reason why we always want to use we always want to kind of constrain our data types as quickly as we can. And definitely during parse events, we want to quickly constrain. Like when we have something coming from a raw text file, and a raw text file can represent anything. When we have something coming from that, we want to quickly give it a very, very precise label of the only thing that thing can ever be for the whole lifetime of the program, and then move on with it, right? So it needs to be as specific as possible. Now, the clever among you might say, well, I can maybe change name doesn't always, that's a first name, right? And, maybe name doesn't always, you can have pets. These are like people names and human names. And well, what if there's pet names and stuff? And so, yes, there will be things like that come into the equation that maybe change and make this not such a great name. But that is just where refactoring comes into place. And this is sometimes just the best bet to kind of keep moving and keep yourself from halting. But we just want to constrain the data types that are going to be passed into here as much as we can. So that's that for that. And so, yeah, so moving on from here, so we constrain and we tell us that, hey, we're making this new variable here. That's going to be a new list of these names. And then we're coming down here to this using text reader to open some file. So, just a note on the using here, you might be saying, well, won't this thing get destroyed by the garbage collector later? Using is always just a little way of telling us that we want to delete this the moment that we exit this scope, because a garbage collector might come next month, but we want to go ahead and delete this thing right now. That's a bit exaggerated, but maybe in the coding lifespan, right, where it runs, quickly in nanoseconds, it might feel like this thing takes forever to get deleted, and it's just hogging memory on your machine. And so we go ahead and close it out using these scope params. So we're here where we read in a line from the file. So in our file of names, this would be one line, this would be one line, this would be another line, and this would be another. So we come in there, we read the lines, and then we inject the information that we read into a new name struct, and then we add that to our list, and then we go ahead and return that list once we've added all the names in from that file in there. So there's actually a bug in this code, but I'm going to keep moving. So that's kind of all that we do there. And then let's move on from that. So let's go over here to a unit test and just start to think about what we might want to test in a unit test. So I'm actually going to delete this. And so when we have our unit test here, it's going to start out blank, of course, like when you make a new unit test. And here I have a new project just for my testing, and I would advise you to do the same. And I just always name it the project name just plus tests. And in here is I duplicated the folder structure down here in testing, and these tests correspond to the test against this folder. So in here, I've created a new events parser because, for some reason we instantiate this class for the parser, and then we come down here and we call its function parser.parse events. So parser events takes a string that is the file name, and we call that, and we get out this variable full of names, and then we move on for the day. So looking at this is actually not a bad unit test. So this actually calls into this function. It gives it a file name. And so we test out this piece of code. We test out this because we're opening up a file. And then we're injecting a line into that file, and we're adding it to the list, and then we're returning that list. So we actually flexed every piece of code in this file. And so now we have to ask the question, okay, we've got really good code coverage now, but have we actually given ourselves any amount of protection here? So if I run this test, we should see that we get green check marks. So I've run my test, my tests are passing, but do I have I really done a good job testing here? Well, the fact of the matter is that we don't really know what we're testing. Like, we haven't tested any feature inside of here. So the feature that I probably care about when I look at this is that I want to make sure that I have grabbed everybody's name out of this file and everything is proper about this. So there's kind of multiple ways that you might attack that. So one way to go about it is that you might say, well, I want to make sure that this file is exactly as I expect it. So when I get a list out, I want that list to be exactly of size 9, and I want Janet in first place, Jack in second, Jake in third, Melinda in fourth, yada, 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 to Jason in ninth. And I might check every single array position and make sure that that's exactly what I want. So let's just kind of code those out and just look at what the pros and cons of each is. So for the first one, wait, test. And, this is really bad naming, but so, for the first one, we're just going to kind of test. Let's give it a good name. We're testing, I'm just going to rename this one to a basic test. And so here, I'm gonna do a more kind of general test, right? So, count is correct test, and we give it every test unit test has to have the test method attribute, and so we'll just make a new parser, kind of like how we have above, and it will read from the same file. We'll kind of optimize this a little bit later. And all we just want to make sure is that dot art equal the names dot count, and oops, I always get that flip. So we know that we know that we actually have 9 in there, and so we just want to make sure that the names is the right one. You did not get, and then here we just kind of print out our error message. You did not get all of the names from the file. Okay, cool. So let's run this code and see what we get from it. So to make this new unit test show up on the right, we just need to go ahead and rebuild this file. And boom, we can see that our labels have both been updated and we have our new test. So when I run both tests, we can see that the first one passed, but the second one failed. So this is actually a beautiful example and a beautiful, nice error message because we use the R equal. I would highly encourage you, for those not new to unit tests or people new to unit tests, make sure I would not use this is true. It's really hard to get useful information. And so you might be kind of, you might feel like, oh, these are really similar, right? Like, you know, you did not get all names. So you might feel like these are really similar, but if I run that and we look at the error message here, we can see that we got far less information. We don't even know what the names.count came back to us as. And so, you know, all around it ends up just not being that useful. So I'm going to go ahead and comment that out and rerun this test, and we can see that we didn't get all the names from the file. We actually got 1, but we expected 9. So, you know, looking back at our text file, everything looks formatted correctly. Everything is on a new line. Should be totally fine. So now we might want to go back and look at our code. Oops. If we look back at our code, you know, I'll give you a couple of moments just to kind of spot what might be wrong on the code right now. All right, did you find it? Well, it turns out that we're not iterating through every line in this code. We only grab the first line, right? So this read line only grabs the first line. There's actually multiple ways that we can approach this problem. So if we kind of look at the list of APIs in here, we click F12, we can look over here and see that there's quite a few little APIs that we could use. There's like a read block. Then there's a read to end. So we can take it out, and you know, maybe we don't really want to work with a file for longer than we need to. So we just want to read the entire file into memory and go about it that way. So there's lots of different approaches that you can take, and none of them are wrong, right? Just different approaches have different trade-offs. So what the approach that I'm going to take, though, because I happen to know that this is pretty optimal, is I'm just going to read. I want to read each line and then inject that into my into a new object, and then dispose of that variable, and then keep moving. So what that means is that I'm gonna do a for. I can do kind of one of two things. So I could do something like this. I could do a while, and then and there's different APIs for this, but while I still have something to read from the reader, I can keep reading lines. So, all right, here we go. So, while line does not equal null, then we just want to do a line equals reader dot read line here. We pop this code up here into here, and this should give us the results that we want. So just going to quickly walk through this. So if we look at this, we are doing our initial read of line, and this is actually pretty this is a little bit tricky. Like, so you might say like, oh, we're kind of doing this initial read of line, but then we're not doing anything with it before we enter into the while loop. Well, we actually do something with it right after we enter into the while loop. And so we kind of have an if statement of sorts here. So if this line is not equal to null, we will go into this while loop and start to process it as appropriate, putting it into the parse names, and then we'll grab a new line and continue through here. So one thing you have to be really careful of is that you don't do something like this, which is actually really easy to do. And so it looks really, really similar. I'm just going to show you what the result ends up being. Ooh. So our test ended up passing. Let's look back and find out why. So we have names.count. Names equal. Well, let's see what happens if we flip it. Well, that's interesting. So that should not pass. The reason that must be passing. Oh, so the reason that must be passing is, so if we actually looked at the list of parse names, we would see probably the first name appears, or the last name is going to appear twice in there. And that wouldn't be the right result. So there's actually a great example here of a unit test not being strong enough to catch kind of a functional issue like that. And so, and you don't want to spend a lot of time debugging your unit test. So if we walk back into our unit test, we can kind of see that, oh, okay, while yes, this qualitative test was really good, like, it totally caught a bug where, maybe we were coding too quickly, and we looked at that using, and that using looked a lot like a while loop. It was totally fine. But then, if we had gotten out to the eventual code, and let's just say that, you had a code, you had it just with a single name, that also would have made it look really good. And so this is why it's important to have a diverse set of unit tests that test all your base cases. And it's why it's a lot more complicated than it looks. So what we do need to do is maybe we strengthen this a little bit more, and we just say, no, I know that I want exact match test. And to make my life a little bit easier, I'm gonna shrink this. No, I actually won't. I'll keep it. No, I am. I'm gonna shrink it. I'm gonna shrink this down to 3 names. Boop. And we're just gonna say, kind of set it up similarly. Var names exact correct names equals new list of, and this is actually a tricky one. It's like, do we want to equate the name or do we want to equate the string? We'll go ahead and equate the name, because that makes our test just a little bit more durable. Correct names, and we'll say new name, and the name will equal, we have our list here. New name is Janet. New name equals Jack. New name with name equal to Jake. Cool. So we have a list of exactly what we expect to kind of come out of that function call up here with a go change, and I'll actually let it show you what it looks like for that to break. So we'll copy this from here. and then we won't steal this condition, though in the future, say that you wanted a different file here, you would probably want to steal that condition as well if you had a completely different file for testing the names. But we'll since we have the same file, we'll let that one handle that. And we'll just kind of do a direct comparison of the names. So for each parsed name in names, we just want to assert.r equal, and the expected would be the correct names. And this is actually pretty tricky, so we're not iterating through both of them, so we don't want to use a for each loop. And this is, there's some kind of comparison theory that you could kind of get into here, but we'll actually end up doing a for loop. So for and I equals 0, I less than, and let's just say correct names, since that's what we're going off of. And actually we are going to pull in the conditional on it. So we are going to say that assert.r equal the correct names dot count, and the what's the name? The names. I'm going to change this to a better name. Extracted names. Extracted names dot count. Did not get the expected number of names back. Okay, and now we're just going to go through and check assert dot r equal the correct names I dot name is equal to the parsed extracted names I dot name. We'll leave the message. Names did not match. Okay, cool. And so this should look through each name that we got back and compare it to this list up here. So let's just see what we got back. This should rebuild for us. Okay, cool. So we got a failure here. So let's see what the issue is. Expected true. Assert r equal. Expected true. Names did not match. Oops. That's me having a brain fart. Okay, cool. Well, let's try one more time. Cool. So now we see that now we're getting exactly what we're expecting. And if we pop back into our code here and we change it back to what I had here, where I kind of intentionally, so this is, like I say, this is where it would have been very easy to make a mistake. If I run this code again, we see now that it failed. And we can see that looks like we expected Janet and we got Jack. So we expected Janet and we got Jack. So we got Jack in the first place instead of getting in the second place. And the first line got completely lost to history. So that's why it's so important to have good unit tests, because even I might not have caught something like this by eye, but a unit test that went in and did an exact check against a very small sample size just to make sure that it was running exactly as expected is actually really nice. Now, there's a trade-off to this. This does make your code a little more fragile. So this makes your unit test a little bit more fragile. So one thing that you might want to do in the future is you might want to generate this text file yourself And so instead of having a text file here, right here, because like I say, now we actually want to give it a unique spelling of Jack. And what will happen is we actually have to rebuild this. So hopefully we don't have to clean it. And then we ran this. We can see that the exact match all of a sudden fails. And it's probably going to say that Jack, oops, to go back to program. We're going to change that back. So now this is failing because Jake did not actually equal Jack. So that's the only trade-off with this approach, is that your code is just a little bit more fragile. But as we saw, this is probably the most ideal test to have in this suite, because it does catch some very, very tricky bugs that would be very hard to catch by looking at it. And you would never want something like that to get into production, because it could be very important, right? That in a list of 0 or a list of 1, that means that it would never grab the first entry in that list. It would always need to grab a second entry out of that list. And so if you have kind of an options menu on your UI, people might expect an options there that isn't present. And if you were in a very serious scenario like healthcare or emergency care and something like that, if you can't get to the first option, then that's a pretty gruesome bug. So, that's why it's important. While it's a little bit more of a fragile test, it's one that is really nice. And like I say, we can get around it by doing something like this. We create this here, and then we could have come down here later and create text file based on list, export that text file, and then once we've done all that setup, now we read it in and then go about our business. That would be the most optimal, the most flexible, and the most dev-friendly approach to making this unit test. Now, one thing that we haven't gone through here, so I need to rebuild this. One thing that we didn't go through is that we actually had a failing unit test over here. This count is correct test. So when we look at this, once again, this is also kind of in the name of supporting unit test. Because we changed some stuff over here to make this test a little bit easier to write, because we didn't want to write 9 names here, we ended up breaking this test. And so that's another trade-off to kind of keep in mind, and just chalk that up to unit test maintenance. That was fairly easy to fix, but now we have a fully working test suite, and when we run everything, we should end up with all greens. So that's just kind of the process of creating unit tests around our code. I just want to show some of the trade-offs and some of the really awesome benefits to it. We went through kind of 3 approaches to the unit test. One was a very basic hit the function and make sure it returns something kind of test. And then the next one was hit it and extract just a little bit more details from it, just the very basics away. And then the last test was a very, very precise, make sure this function is behaving exactly as I expect it to when given the exact set of input. And like I said, we saw that sometimes it's not very good to have a disjoint data object, have disjoint data objects. So this list does not know anything about this file here. So ideally, we would want to connect these lines of code together and have them joint so that this unit test flows and is maintained by itself, and it makes life easy to maintain it towards the future. And the same here, right? We saw that by having a name file out here that exists by itself, independent of this number, now we face an issue that if someone else changes that file, we now end up breaking a lot of tests. And so you could imagine if this test suite had 50 tests inside of it, we might have broken every single test in there that depended on this file. So, and it's not always a good idea to take the opposite approach of, well, I'm going to make a different file for each unit test. That's not always the best approach. I would just say create the file inside your unit test as you go, and that would be the best. So anyway, we that was kind of the process of building the unit test. So just as the last point before we close out this video, because it is getting long, I just want to show you once again, now that we have a fully functioning test suite that works just as we expect, what is this unit test really shielding us from now? So if we go back to our piece of code here, and like I say, I told you there were multiple ways that you could implement this function, right? So you could come back to here, and we could say that instead of doing a read line, I kind of want to read the entire block in, and then I want to do a split on the new lines. So let's see. So if I comment this out really quickly, and let's just say var whole file equals reader dot read to end. And we're using a synchronous call too. You can see that there were some async versions of this call. Usually you're going to want to use async in a server setting, but here we're just doing synchronous because it's a very simple program, and we don't want to set up async. It's not always good to use async because it can reduce the readability of your code, and provides minuscule speed up benefits. So now we've read in everything from this file, and so it should look like a string that just has like new lines. So if we copy and paste this as a string into C#, it should just look like that. So what we can do now is maybe say names as strings equals whole file dot, and we want to split on a new line. Oops. So we split on the new line, and so now we have for each var name and name as strings, and then here we just kind of can copy this code that we had here. So that gets changed to name. Boom, boom, boom. Cool. So now all we have to do, recompile, and boom. So, this is just a great example of, we did get some failures over here. If we kind of jumped over, saw the error messages, we got expected 3 and got back 4, and it's like, okay, oh, maybe there was an extra new line in here, right? And there was, right? So all we have to do is resave that file, and if we rebuild and we run it again, now we have all green. So that was a beautiful example because I didn't even know about that new line in names.txt. So that was a great example though of, this is the beauty of what a unit test coverage on a function can give you. You can write a completely different implementation of your file. I didn't even look at this. I've never written like this before. And I was able to write all of this from end to end and completely rely on my unit tests to give me a safety blanket. And it failed appropriately, as it should. And I have a lot of confidence that my unit test is correct for most of the useful base cases. There's a lot of edge cases, and you shouldn't try to code unit tests for all your edge cases. But for the very real possible set of inputs for names.txt, I felt very confident with the unit test suite I had set up. And so I was able to come over here, implement it with a completely different strategy. And for people that might not recognize what the strategies were, with here, The strategy was to go through that file and read it line by line. So I read this line, put that into a struct, and then added it to the list. I read that line, put it in a struct, add it to a list. I read this line, put it into a struct, add it into a list, and then I closed this file. The second approach reads the entire file. It doesn't close it. We could optimize it and close it, but it reads the entire file into a string that has new lines. And if you're not familiar with kind of how strings get pulled in, that string was gonna little hidden characters here. Well, it had little hidden characters like this at the end of each line, right? And so that string got pulled into, it just got pulled into a single variable in C#, and then in that variable I was able to do this call called split. And what split does is, it's very similar to JavaScript split. It just looks for this new line character, and then it cuts off the chunk up to that point, and then starts a new chunk right after this character. So in this case, we had a chunk. It goes like read, chunk, end chunk, read, end chunk, read, end chunk. And in the last case, we had this new line here, and it actually read that one, and it read an empty character. And so our last entry that was saying 4 was just like an empty character array. So all useful things that you should go play around with, print out to the console if you don't know what's happening. Just play around with it. Open this file in like Notepad++, and maybe go into a debugger and try to see what this is looking like as it's flowing through. So anyway, continuing on, we went into this for each loop, and we looked at each name that was in this array. So split throws everything out as an array of strings, and we just iterate through that array of strings and just inject that into a struct like we did up here. And all that stuff looks very the same. That's why I copied it. And then we go ahead and return out, and that's the end, right? Like I say, one of the things you want to do usually is you want to do like a using kind of statement here, just to make sure that things get closed in a reasonable time span. But oops. Actually, sorry about that. You don't have to do that because you've already done it up here. But yeah, because we did this code here, we didn't need to stay inside the using statement. We could have gone ahead and closed out that file. And that can kind of encourage people to not manipulate the file anymore. So this code could have kind of come out here at the end. But those are just optimizations that we'll kind of talk about in the future. So there's a trade-off to this also, to this strategy that we'll also talk about maybe up here in increasing speed. But yeah, that is pretty much the example I wanted to show, and you got to see firsthand just where that can kind of break down, and just what the immediate benefit is of that. So thank you for spending your time watching this, and I look forward to discussing some further topics in refactoring with you. As I mentioned before, this is the first video in a set of videos just talking about refactoring. The next few videos should be a lot quicker since this was a lot of setup, but this set us up with our unit test suite so that we can move to the next steps of refactoring a lot easier. So thank you for your time, and have a nice day.